A state of emergency has been declared on the Greek island of Santorini following several days of tremors. I work on the island, I've lived here for years, but nobody was expecting this.
A state of emergency has been declared on the Greek island of Santorini following several days of tremors. I work on the island. I've lived here for years, but nobody was expecting this. Something strange and unsettling is happening beneath Santorini, said a local resident. Authorities have just declared a state of emergency after the island was rocked by its most powerful earthquake yet. But that's not the most shocking part. Scientists have discovered that 3 million cubic meters of magma have suddenly vanished from the volcano's chamber. A newly formed dike suggests that the magma hasn't disappeared, it's on the move. Seismic data now reveals unstable geological activity, with shifting molten rock causing the land to inflate and deflate in unpredictable ways. Could this be a warning of something far more dangerous? Is Santorini on the brink of a major eruption? And what does this mean for the rest of the region? Let's break down the science behind this alarming mystery. Santorini earthquake triggers state of emergency amid growing volcanic concerns. Authorities in Greece have declared a state of emergency following the most powerful earthquake to hit the island of Santorini in recent history. This seismic event has intensified fears about the volcanic activity beneath the island, particularly after geologists discovered that approximately 3 million cubic meters of magma had mysteriously vanished. The sudden disappearance of this molten rock, along with the formation of a dike, has raised alarms about potential eruptions and further geological instability. Recent research has provided a clearer picture of the dynamic processes occurring within the magma chamber beneath Santorini. This new data sheds light on the movement of magma, the accumulation of molten rock beneath the surface, and the accompanying seismic activity. Scientists have observed inflation and deflation of the land, indicating significant geological shifts. Geological experts release official update. Geological experts from leading institutions have released an official update titled Update Note on Ground Deformation at Santorini which presents a preliminary calculation of the magma volume involved in the ongoing seismovolcanic crisis. This research, conducted by organizations such as the Centre National de la Recherche Scientifique in France, the National Observatory of Athens, the University of Poitiers Department of Geology, and the National and Kapodistrian University of Athens Department of Geology and Geoenvironment, offers a critical assessment of the situation. The update provides new insights into the seismovolcanic activity affecting Santorini, analyzing data from Global Navigation Satellite System, GNSS, time series and preliminary models to interpret ongoing land deformation. Colombo underwater volcano raises additional concerns. One of the most concerning revelations involves the nearby Colombo underwater volcano, which sits just 7 kilometers, 4 miles, off Santorini's coast. In December of the previous year, researchers identified a shallow magma chamber beneath Colombo that has been steadily filling. This chamber has now reached levels comparable to those recorded before Colombo's last eruption. Given Colombo's history of producing highly explosive eruptions, the recent seismic activity near its main crater and several smaller craters has caused significant concern among experts. Seismic monitoring stations have played a crucial role in tracking these developments. Scientists installed additional monitoring equipment last year, and 4 more stations were added recently to enhance data collection. However, a major challenge has emerged due to fragmented ownership of these stations and a lack of collaboration between the institutions managing them. This situation has created gaps in data sharing, making it difficult for researchers to gain a full and accurate understanding of the volcanic activity in the region. Inconsistent data complicates analysis. A significant obstacle in analyzing Santorini's volcanic activity lies in the inconsistency of available data from GNSS stations. Discrepancies have surfaced regarding the number of stations currently in operation. Some stations appear on monitoring maps, but their exact status and ownership remain unclear. These inconsistencies have made it difficult for scientists to gather a comprehensive dataset. Comparing the current situation to the previous volcanic unrest between 2011 and 2012 highlights the reduction in monitoring capabilities. During that period, approximately 10 stations actively monitored ground deformation and seismic movements. After the crisis subsided, many of these stations were removed, leaving only 3 operational today. This significant reduction has limited scientists' ability to detect early warning signs of potential eruptions. Ground deformation accelerates in early 2024. Despite these challenges, researchers have managed to analyze recent data from the few active monitoring stations. Among them, the Sant station has provided some of the most crucial information due to its proximity to the ongoing inflation zone. Let's see what they have to say. Ground deformation has accelerated in early 2024. The Sant station, positioned closest to the inflation zone, has detected significant changes in land movement. Alongside data from the HOS and Urania stations, scientists have identified a pattern of accelerated ground deformation beginning in mid-2024. Since January, these movements have intensified, showing a pronounced upward shift in the landscape. Elevation measurements from the Sant station reveal a steady increase, with land uplift rising from 60 millimeters to over 100 millimeters. This upward displacement strongly suggests that magma continues to accumulate beneath the surface, exerting pressure on the land above. Although the HOS and Urania stations have recorded less dramatic shifts due to their distance from the inflation center, the data still supports the overall trend of an expanding magma chamber beneath Santorini. These observations indicate that the primary area of concern lies near the Sant station, where monitoring maps have identified a smaller volcanic structure. Updated data highlights 3 critical movements. The most recent data, last received on February 11th, provides a clearer picture of the ongoing geological activity. Scientists have identified 3 critical movements that suggest significant changes beneath Santorini. First, researchers observed a pronounced upward displacement, indicating that magma is pushing toward the surface. Second, they detected a consistent northward drift, revealing shifts in land positioning caused by underground activity. Finally, the data showed a marked shift toward the northeast, which could point to structural changes within the magma chamber. These movements suggest that magma is not only accumulating but also changing the stress distribution in the surrounding geological formations. Such changes could lead to further seismic activity or, in a worst-case scenario, an eruption. Is Santorini on the brink of an eruption? With a recent rise in seismic activity, geologists are closely monitoring the situation to determine whether these movements signal an imminent eruption or another phase of inflation without an immediate event. While Santorini has experienced periods of volcanic unrest in the past without leading to an eruption, the current developments resemble the patterns observed before previous volcanic events. A critical factor in assessing the risk level is the behavior of the Colombo volcano. Since its magma chamber has already reached pre-eruption levels, any further accumulation could trigger an explosive event. This, combined with the uncertainty surrounding Santorini's magma movement, has prompted scientists to intensify their efforts to monitor the region. Despite the limitations in data collection, researchers are working to fill the gaps in monitoring networks. Additional seismic monitoring stations, improved collaboration between institutions, and more frequent assessments of GNSS data could provide better insights into the evolving situation. The mysterious shift beneath Santorini ***. A closer look at the seismic activity around Santorini reveals a pattern that has been intensifying for weeks. Since the initial earthquake swarm, seismic events have consistently migrated toward the northeast. However, what makes this even more concerning is the timing of additional land deformation. Around January 20th, researchers detected the start of a deflationary trend, meaning that part of the land appeared to be sinking. But just 9 days later, everything changed. An abrupt acceleration in movement toward the north-northeast began, and that shift has not stopped. A second earthquake swarm struck on January 26th, following closely on the heels of the first. However, it was not until January 29th that seismic stations officially detected these movements, marking this as the start of a new phase in the unfolding crisis. What is causing this sudden increase in activity, and why is the land moving in different directions at the same time? The answers may lie deep underground. **** magma on the move. What Iceland's volcanic activity tells us ***. Scientists have seen similar patterns before, most notably in Iceland, where magma migration and surface deformation have occurred almost monthly since November 2023. One of the most striking examples happened in November when magma vacated a chamber beneath the Svartsengi region. No eruption took place, but the land still shifted, mirroring the current situation in Santorini. Researchers describe this process as being similar to stretching a rubber band. When magma accumulates in a chamber, it slowly expands a surrounding rock, just like pulling on a rubber band. But once the stress exceeds its elastic limit, the magma is forced outward, seeking the path of least resistance. Sometimes, this process results in an eruption. Other times, the magma remains underground, spreading through cracks and weak points in the rock. This hidden movement, known as magma intrusion, is often the precursor to a volcanic event. So, is Santorini experiencing a prolonged magma intrusion, or is something even more complex happening beneath the island? **** signs that magma is carving a new path ***. One of the biggest indicators of magma migration is seismic activity. As molten rock pushes through the earth, it generates vibrations similar to those caused by mining operations. The more magma moves, the more shaking occurs. A dramatic example of this happened in Iceland on November 10, 2023, when a massive magma intrusion formed a 15-kilometer-long dike. The intrusion stretched toward Grindavik and even extended into the sea, triggering intense seismic activity. Now, a similar process may be unfolding beneath Santorini. The persistent earthquake swarms suggest that magma could be carving a new underground path, like what happened in Iceland. But scientists are still debating one major question: why is deflation occurring at the same time? ***, the confusing case of land uplift and deflation ***. When magma accumulates beneath the surface, it usually causes the land above to rise, much like inflating a balloon underground. However, if magma leaves a chamber and moves elsewhere, the land begins to sink, producing a deflationary signal. This is exactly what researchers have observed near Santorini. As the second earthquake swarm intensified, land deflation was detected at the same time. This suggests that magma may be shifting from one chamber to another rather than building up in a single location. The timing of these shifts remains uncertain, but scientists are carefully analyzing seismic and ground deformation data to pinpoint what is happening. Another factor complicating the situation is Santorini's complex network of fault lines. The island sits at the intersection of multiple tectonic boundaries, meaning that any magma movement could interact with these fault zones. If magma infiltrates a fault, it could act as a trigger, causing additional earthquakes and prolonging the seismic swarm. This interaction could even create new pathways for magma to move, sustaining the activity for longer than usual. In the worst-case scenario, this chain reaction could set off secondary fault ruptures, potentially leading to more significant seismic or volcanic events. Interestingly, these movements align with the trajectory of the recent seismic swarm, reinforcing the idea that magma is migrating beneath the island. The question now is whether this activity will continue to intensify or if it will stabilize before an eruption occurs. ***, looking at time series data from early 2025 ***. Researchers have identified key trends in ground deformation. The year began with an initial period of inflation, an increase in land elevation, before a sharp deflation occurred around January 29th. This sudden drop coincided with the onset of a powerful earthquake swarm that rocked the region. A brief stabilization followed, but another significant drop soon mirrored a second wave of intense seismic activity, including a magnitude 5.3 earthquake recorded at the time. This sequence of inflation and deflation has left geologists with one pressing question: did magma escape from the chamber? Interestingly, following these seismic events, elevation levels once again began to rise. This suggests that as magma moved out of one chamber, deeper sources may have started replenishing the reservoir, creating a continuous cycle of inflation and deflation. This phenomenon is not unique to Santorini. Similar patterns have been extensively documented in Iceland, where repeated cycles of magma migration have fueled both eruptions and land deformation. Interpreting the ground deformation signals ***. When comparing the data from HIOs with monitoring stations farther from the detected uplift zone, such as those in the southern region of Santorini, a slightly different picture emerges. While the southern stations continue to record deflation, the general northward and eastward movement persists across multiple locations. This shift raises a key question. What exactly is driving these changes? Some scientists have proposed that this could be a purely tectonic process, arguing that the movements align with natural plate shifts in the region. However, the evidence increasingly suggests a strong magmatic component. Given that the greatest land rise has been detected directly beneath Santorini, it appears more likely that magma intrusion is playing a dominant role. If a new magma intrusion is forming beneath the island, it could create depressions on either side of the intrusion, leading to localized subsidence. This type of deformation has been observed in Iceland, where magma-driven shifts often form valleys parallel to the intrusion path. However, due to gaps in the available data, uncertainty remains about the exact nature of these movements. A purely tectonic explanation seems unlikely, particularly given that past patterns of deformation in Santorini have historically been linked to volcanic unrest. ***, could Santorini be entering a prolonged magmatic phase? If magma is indeed moving beneath the island, one possible scenario is that enough has been displaced to temporarily relieve pressure, slowing further deformation, at least for now. If this is the case, seismic activity could subside unless additional fault lines are triggered or new magma pathways continue to develop. Another possibility is a balanced flow scenario, which is often seen during active eruptions. In this situation, magma continues to rise from deeper sources while an ongoing eruption allows for gradual pressure release. If such a process is unfolding beneath Santorini, it could extend the period of ground deformation and seismic activity rather than leading to an immediate eruption. Inside the Earth, magma moves through complex networks. Magma moves through complex subterranean networks, carving out pathways that allow molten rock to travel toward the surface. As these conduits form, seismic activity often decreases, much like how a tunnel stops generating vibrations once excavation is complete. Typically, before a volcanic eruption or significant magma intrusion, an intense swarm of earthquakes precedes the event. This is then followed by either an eruption or a sudden drop in seismic activity, indicating that the system has settled. However, the continued seismic unrest in Santorini presents an anomaly. If magma intrusion is causing the ongoing shaking, why has it not yet resulted in an eruption? Fault lines may be amplifying the activity. One major complicating factor is Santorini's intricate fault system. The region sits at the convergence of several tectonic boundaries, which means that even small magma intrusions could trigger larger seismic disturbances. If magma is interacting with fault lines, it could create additional pathways for movement, allowing it to spread across different sections of the crust. This, in turn, could sustain the current earthquake swarm rather than allowing it to dissipate naturally. Furthermore, if the faults continue to rupture, they could create a chain reaction of seismic and volcanic activity. This makes it all the more crucial for scientists to continue monitoring the situation in real time. Despite progress, gaps in data remain. Despite the progress in tracking Santorini's geological activity, gaps in data remain a serious issue. Many monitoring stations that were active during previous volcanic unrest have since been removed, leaving scientists with fewer resources to study the current crisis. Given the complexity of the situation, researchers emphasize the need for better collaboration among institutions managing the monitoring equipment. Without complete datasets, it is difficult to form a clear picture of what is happening beneath the island. Nevertheless, the most recent GNSS readings, particularly from the Sant station, indicate that the ground is continuing to rise, move northward, and shift toward the northeast. These movements closely align with the trajectory of the most recent seismic swarm, reinforcing the idea that magma migration is underway. Unlike previous periods of inflation, the current deformation field has shifted, placing the estimated magma source in a different location than the one observed during the 2011 to 2012 unrest. This change suggests a dynamic system with magma intrusions occurring at varying depths and locations beneath the island. *** tracking magma injection. How much has accumulated? *** By analyzing observed deformation trends, researchers have estimated that approximately 6.5 million cubic meters of magma have accumulated within the chamber. While this volume is not particularly large compared to some Icelandic eruptions, where influxes often exceed 12 to 13 million cubic meters, the composition of Santorini's magma makes even moderate volumes of intrusion a cause for concern. Santorini's volcanic system differs significantly from Iceland's fissure eruptions, which tend to be less explosive in nature. The island's history of powerful eruptions, driven by more viscous magma, means that even a moderate influx can increase the risk of explosive activity. This estimated volume of magma corresponds to a maximum vertical uplift of approximately 90 millimeters (9 centimeters) at the center of the deformation field. If inflation has occurred at a steady rate over the past 170 days, this suggests a daily uplift of about 1.1 millimeters, totaling approximately 33 millimeters per month. While these measurements may seem small, they represent significant movement when considering the geological timescales typically associated with volcanic activity. ***, recent changes suggest a complex magmatic process. One of the most revealing aspects of the study involves the changes recorded between early January and mid-February 2025. If the volume of magma within the chamber has changed significantly during this period, it could provide key insights into whether magma is actively intruding, exiting, or redistributing within the system. Measurements taken at the SAMP monitoring station indicate that deflation amplitude has now reached nearly half of the previous inflation amplitude, pointing to a complex dynamic at work. This shift could suggest that some of the accumulated magma has drained elsewhere within the volcanic system or is undergoing internal pressure adjustments. While a sudden drop in inflation could indicate that magma is moving toward the surface in preparation for an eruption, this is not the only possible explanation. In some cases, magma intrusion can cause land deformation without leading to an eruption, as the molten rock spreads through underground fissures rather than forcing its way upward. ***, why seismic activity remains a major uncertainty. One of the most puzzling aspects of the current situation is the persistence of seismic activity. Typically, after significant ground deformation, seismic activity either decreases sharply, suggesting that the system has stabilized, or increases rapidly, leading to an eruption. However, in this case, neither scenario has occurred. Instead, seismic activity has continued at a steady rate, with no clear signs of resolution. This prolonged unrest raises key questions about the underlying processes at work. One possibility is that the magma chamber is experiencing pressure fluctuations, leading to intermittent releases of seismic energy. If this is the case, the deformation cycle may continue for some time, potentially delaying any eruption. Another explanation is that magma is interacting with fault lines beneath Santorini, triggering additional seismic activity as it moves. The island's unique geological setting makes this a plausible scenario, as previous studies have shown that fault movement can prolong periods of seismic and volcanic unrest. ***, predicting the next phase of Santorini's volcanic activity. With new data emerging daily, scientists are working tirelessly to determine the next phase of Santorini's volcanic activity. The island's complex geological system presents multiple possible outcomes, each carrying different risks and consequences for the region. While some scenarios suggest that the current unrest may subside, others point to a more prolonged period of activity or even a potential eruption. ***, Scenario 1. The magma chamber reaches equilibrium. One possibility is that the recent deflation represents a natural pressure adjustment within the magma chamber. If this is the case, the system may stabilize without leading to an eruption. In this scenario, seismic activity could gradually subside as internal pressures equalize. When magma intrusions occur, they do not always culminate in eruptions. Instead, magma may settle within existing underground reservoirs, reducing the stress that initially triggered the deformation and seismic activity. If equilibrium is restored, the island could experience a temporary period of quiet, with fewer earthquakes and less ground movement. However, this scenario does not guarantee long-term stability. Magma intrusion could resume at any time, reigniting unrest beneath Santorini. Even if the chamber stabilizes temporarily, new injections of magma from deeper within the Earth could restart the inflation cycle, leading to renewed seismic swarms. Scientists emphasize that while equilibrium may be achieved in the short term, Santorini's volcanic system remains dynamic and unpredictable. Scenario 2. A prolonged inflation-deflation cycle. Another possibility is that Santorini enters an extended period of inflation and deflation, similar to cycles observed in other active volcanic systems such as Iceland and Italy's Campi Flegrei. In this scenario, magma would continue migrating through subterranean chambers, triggering periodic seismic swarms without necessarily breaching the surface. This scenario would not lead to an immediate eruption, but would keep the island's volcanic system in a prolonged state of unrest. As magma moves through the crust, some areas may experience uplift while others undergo deflation, creating a fluctuating pattern of land deformation. A prolonged cycle of inflation and deflation could stretch on for months or even years. During this time, ground deformation would continue in waves, and seismic activity would remain elevated. However, without a clear pathway to the surface, the magma might never erupt, instead shifting between underground reservoirs. While this outcome would avoid a large-scale eruption in the short term, it would make long-term monitoring essential. The risk of an eruption would not disappear. Instead, it would remain an ongoing concern, requiring scientists to track changes in ground movement, gas emissions, and seismic patterns to determine whether new warning signs emerge. Scenario 3. Magma moves closer to the surface. A more concerning possibility is that the current deflation is occurring due to magma migrating upward rather than outward. If this is the case, Santorini could be approaching a new phase of volcanic activity. The persistence of seismic activity, especially when combined with continued ground deformation, suggests that magma remains in motion. If this movement is primarily vertical rather than lateral, an eruption could be on the horizon. A key warning sign would be an increase in gas emissions. As magma rises toward the surface, it releases gases such as sulfur dioxide, which can be detected in volcanic plumes. If scientists record a sudden rise in these emissions, it would indicate that magma is nearing the surface and that an eruption could be imminent. Additional factors, such as the acceleration of land deformation or changes in the frequency and depth of earthquakes, would also support this possibility. If tremors become shallower and more frequent, it could mean that magma is breaking through layers of rock as it ascends. In the event that magma reaches a critical pressure threshold, an eruption could follow. The scale of such an event would depend on several factors, including the volume of magma involved, the composition of the molten rock, and the presence of water in the system. The importance of continued monitoring. Given the complexity of Santorini's volcanic system, researchers stress the importance of continued monitoring. The current data provides valuable insights, but gaps in historical observations make it difficult to predict long-term trends with certainty. Authorities are working to ensure that monitoring efforts remain as comprehensive as possible, with scientists closely tracking land deformation, seismic patterns, and gas emissions for any further changes. While the situation remains uncertain, one thing is clear. Santorini's geological activity is far from over. Whether this period of unrest leads to an eruption or continues as part of a long-term magmatic cycle, scientists will remain vigilant in their efforts to understand and anticipate the island's next move. When magma pushes into a dike. When magma pushes into a dike, its dimensions usually provide clues about the intensity of an impending eruption. Scientists estimate that if this dike stretches approximately 30 kilometers in length and spans 1 kilometer in width, its thickness should be significantly greater. However, current data suggest an unusually thin measurement, just 10 centimeters. Such small dimensions are uncommon, raising questions about the nature of this intrusion. While rare, similar cases have been documented in other volcanic regions, suggesting that the scenario remains plausible. If the magma remains trapped within this narrow dike, it could either cool and solidify underground or continue to expand until pressure forces it to the surface. Seismic clusters confirm magma movement. One of the strongest indicators of an active magma intrusion is the concentration of seismic activity around the suspected dike. Clusters of earthquakes have continued to form in the same area, further supporting the idea that molten rock is pushing through fractures in the Earth's crust. The question now is whether this movement will culminate in an eruption or if the system will stabilize. Adding to the puzzle is the rapid ground displacement toward the north. Scientists have yet to find a clear explanation for this shift, as it does not directly align with previous patterns of deformation in the region. To investigate further, researchers installed an additional GNSS receiver on Enidros Island on February 12. Although small, Enidros Island is strategically positioned east of Santorini, making it an important observation site for tracking land deformation and magma movement. Early readings from the new monitoring station have already provided some preliminary insights, but with only a few hours of recorded data, the full significance remains unclear. As researchers continue collecting information in the coming days, they hope to gain a clearer understanding of the broader dynamics of the region. If consistent upward displacement is detected on Enidros Island, it could indicate that magma is spreading laterally beneath the region, increasing the risk of an eruption. The Colombo Volcano, a major blind spot. While much of the focus has been on Santorini, another major concern lies just a few kilometers offshore, the Colombo underwater volcano. Located near the epicenter of the ongoing earthquake swarm, Colombo has shown signs of magma accumulation in previous studies. However, real-time data from its monitoring stations remain scarce. Given Colombo's history of explosive eruptions and its role in shaping the region's tectonic activity, any increased unrest at the volcano could be crucial in understanding the larger picture. Without frequent updates from monitoring stations, researchers are left with a significant blind spot in their assessments. The absence of real-time data makes it difficult to determine whether Colombo is experiencing similar deformation patterns or if it remains stable. If new seismic activity emerges near the underwater volcano, it could indicate that the magma movement beneath Santorini is more extensive than currently understood. Predicting the next phase of Santorini's volcanic activity. Predicting the next phase of Santorini's volcanic activity remains a challenge, but recent findings offer valuable insights into the processes at work beneath the surface. The migration of magma into a dike, continued seismic clustering, and unexplained ground displacement all point to an evolving system that warrants close monitoring. The coming weeks will be critical in determining whether the current unrest is an early warning of a new eruption or simply another phase in Santorini's long history of volcanic adjustments. If deformation continues at a steady rate and seismic activity remains persistent, the possibility of an eruption cannot be ruled out. However, if pressure within the magma chamber stabilizes, the system could enter a prolonged period of inflation and deflation without leading to an immediate event. Alright, so that's it for this video. If you want to watch more amazing content like this, check out some of our other videos. Bye.